Hello, my good friend. It's been a long time.
This was the TV channel that made Michael Jackson.
I'm a boneless fish, bosh, bish. No need for relish, cause I'm so delish. You can have me with a glass of squash on a big plate if you wanna be posh. With chips and well swish, and a splash and a splish, acetic acid if you wish. Ionic alkali halide from period 3. There's no other dish with a fish like me. I'm a boneless fish, bosh, bish. No need for relish, cause I'm so delish. You can have me with a glass of squash on a big plate if you wanna be posh. Chips I'm well swish, add a splash and a splish, acetic acid if you wish, ionic alkali halide from period 3. There's no other dish with a fish like me.
This was the TV channel that made Michael Jackson. Channel.
Question time.
Question time. Who was the inventor of laughing gas? Nitrous oxide alters brain function through several key neurotransmitter pathways.
Magnesium,
Powdered polytetrafluoroethylene.
PTFE,
Stoichiometrically 2 parts Teflon to 1 part magnesium.
Finely ground, intimately mixed.
The activation temperature for this reaction is about 500 degrees Celsius. It is an exothermic reaction that can reach as high as 2000 degrees Celsius. This gives off a distinct infrared signature which acts as a decoy for heat-seeking missiles.
Yo, buddy, you might feel calmer if you have some needles. I'm just gonna play it safe. I can pee in your pants.
No, not that MTV.
Chemist from Vesuvius.
The enthalpy of formation. The lattice energy between fluoride and magnesium is exceptionally high. The PTFE monomer, that's the tetrafluoroethylene molecule when it's part of a polymer chain, has a standard enthalpy of formation of minus 830 kilojoules. The negative value indicates that forming the unit from elemental carbon, graphite, and fluorine gas releases 830 kilojoules of heat and is therefore an exceptionally stable molecule. Stable as in resistant to future reactions. To break those bonds again, that energy must be put back in. Just to be clear, carbon and fluorine do react to create tetrafluoroethylene gas, but it is not industrially produced this way. In the presence of an antimony pentachloride catalyst, chloroform and anhydrous hydrofluoric acid react to produce chloro-difluoromethane. Thermal cracking of this intermediate yields tetrafluoroethylene. Lysoxenic acid peroxide then initiates radical polymerization via addition across the carbon-carbon double bond. Ammonium persulfate is another initiator. This reaction is performed underwater under high pressure. Phyton acts as a binder and is also a fluoropolymer like Teflon. When the fluoropolymer breaks down, fluoride reacts with magnesium. It leaves behind carbon, which further oxidizes this carbon dioxide. It produces a high-intensity gray-body thermal radiation continuum, driven by incandescent carbon soot. Basically, atmospheric oxidation of soot. I should just interrupt here to add, these are two separate phenomena. The steady radiation from incandescence, followed by the thermal energy of oxidation, which heats the surrounding gas molecules.
90% of all United States combat aircraft losses over the past 25 years have been due to infrared homing missiles. The main materials used in the infrared sensor are lead sulfide, indium antimonide, and mercury cadmium telluride.
Here, a jet exhaust plume is the infrared source. This hits a sawtooth reflective disc that diverts the beam to hit the infrared sensor. Due to the photoelectric effect, an infrared sensor allows a voltage signal to pass or not pass, depending on the type of light reaching the semiconductor. This Seeker missile uses the 1.5 eV bandgap of cadmium telluride and the 0 bandgap of mercury telluride to perfectly tune the semiconductor to match the infrared wavelength emitted by jet exhaust plumes. These mercury-cadmium telluride semiconductors are cryogenically cooled to reduce noise and increase sensitivity. As the missile spins, using internal mirrors, the sensor sweeps across the target area in a rosette pattern to track heat signatures. The addition of ferric oxide, that's iron, all the way to its +3 oxidation, not only provides oxygen, causing a thermite-like reaction with the magnesium, it also serves as a Lewis acid catalyst, lowering the energy That's the temperature in which the polymer can release its reactive fluoride ions, speeding up the rate and intensifying the reaction, producing the decoy signature much faster.
Where are we going this time? Is this bipedal primates rubbing sticks or 2026? All we wanna do, be entertained and learn chemistry. Gonna go through time. The universe doesn't play dice. Remember Lucius. Take me away. Back and forth through a journey. You better promise me I'll be back in time. Following back through time. Gotta go back in time. Sliding back in time. Temporal Rosen Bridge. Gonna get us back in time. Go back. Yeah.
The titan of electrochemistry, the greatest mind the world would know.
Compound interest.
Mirror, mirror on the wall, I'm the greatest scientist. Just call me Sir Humphrey the First Baronet. Some prefer Mr. President of the Royal Society, inventor of the safety lamp, the Davy lamp. Stevenson stole my idea. The North of England chose his design over mine. But mine is better, it's just an after it can burn. But it has a metal mesh cage, no flame can travel through the mesh. So might as well be safe when there's methane in the mine.
This works by heat transfer, lowering the temperature of the gas below its ignition temperature.
Ooh, very clever. Very clever.
Its thermal conductivity is dictated by the hole size and the thickness of the material, and the thermal conductivity of the metal.
You built a safety lab, the honor was your right. Yeah, when my iron ring brought invisible power to light. You spoke of jealousy, you voted with a no, and tried to block the path where knowledge ought to go. I bear no bitter shield, no malice in my chest. I only sought the laws by which the world is blessed. You say I stole your life, you say I took your name, and cast your heavy shadow across my humble fame. But truth is not a prize that one man holds alone.
Today we will make potassium. 9 grams of calcium metal is chopped up with a slight excess 35 grams of potassium chloride, and hydrous conditions are required unless you aim to consume reactants by generating calcium oxide and hydrogen gas, with the risk of explosion as well. The equilibrium between potassium chloride and calcium prefers to remain as calcium and potassium chloride. So, following the old Le Chatelier's principle, in order to produce potassium, we must first melt the reactants so that they can come in contact and react. Then we must remove potassium as it forms. Dynamic chemical systems respond to applied stress by shifting the position of the equilibrium to partially offset any changes. In this case, product removal promotes product formation. Le Chatelier's principle can account for concentration, pressure, volume, temperature, phase composition, or electrical potential. Hence the stainless steel high temperature distillation apparatus. Sound effects.
I couldn't cut the calcium. It's 2 valence electrons for a very dense lattice.
The reactor and condenser are made from 316 stainless steel pipe fittings. And I have a hose bar fitting with some PTFE tubing leading into a collecting vessel containing mineral oil. This is to prevent any potassium coming in contact with air. The reaction must take place above 700 degrees Celsius. I think I set my furnace to go up to about 900 at one point to try and push the reaction forward. The distillation took about 2 hours. As a proof of concept, I was able to produce a small amount of potassium. Just for a comparison, this is how calcium reacts with water, to prove that we do indeed have potassium. The test tube felt a little bit warm, but the reason potassium is so reactive is because it has a large radius and it has only a single valence electron, which is far away from the nucleus, meaning it is quite willing to give away its electron.
Kick up your heels and smile. Talking Wednesday style, I'm in your face, I'm at large, I'm living it to the max, I'm waxing, I'm retard maxing. Yeah, so make no mistake, cause I'm here to order steak and then eat too much cake. Stand on a rake, forget to use the handbrake, learn to swim in the lake beneath the overpass on the motorway. I'm a genius at play, walking to a different beat, but I'm not gay. Talking Wednesday style, in your face I'm at large, so kick up your heels and smile.
Copper and zinc, galvanic might, redox potential, electrolyte.
A hair on my tongue.
Massively at scale, in the basement of the Royal Institution, running in series, these are my humble batteries.
Hello, welcome back. Back in time. Our causal anomaly this week is going to visit Professor of Chemistry at the Royal Institution. The year is 1807. Back in time. The man is Humphrey Davy, almost 100 years before the electric power grid. He created continuous DC power from hundreds of voltaic cells consisting of brine-soaked pasteboard sandwiched between zinc and copper plates. He later switched to an acidic electrolyte which, through faster redox, produced much higher power density. This was a dilute nitric acid, which at the time was called nitrous acid. Of course, not to be confused with nitrous acid. So what did he need hundreds of these for? He was the inventor of electrochemistry, and one of the most brilliant scientists of all time.
I think you'll find that me.
Hey, Hump. Just back from your travels, I see. Didn't expect you back here so soon.
Sir, you're one of the greatest chemists I know, and I have met a lot.
Brilliant, yes.
Have they given you your knighthood yet?
I certainly am. We know this. But it seems that my lowly assistant has been attracting admiration in the field. An elite scientist upstaged by hacks and plagiarists who copy my knowledge, which is mine. Then they discover things I was about to discover. You see, I was inevitably going to discover them. Me.
Not him.
Your name is a blight, you're stealing my life. Lies are filling my head, filling up my mind. All these visions of the glory should be mine. I'm the master of the current, electron flow. How are you the one to make the headlines grow? Faraday's fame, it's a voltage spike. Pain I can't evade, this electrolysis of hate.
Electromotive force, voltage, flows through a conductor when it's in a changing magnetic field. Faraday described this. Clerk Maxwell, some time later, did the math. And Lenz had his law about the direction in which the current travels.
Now you get fellowship nominations.
I will not have it. I should lock him in that cage he built. Oh, yes, old Mickey Faraday. A man of ambition like yourself. Don't let your ego get the better of you. The reason I've come is I want to observe what you're currently, no pun intended, working on.
Ooh. What is this? This feeling. I need to dance. Mr. Lucius, come and join this momentous moment. I made another discovery. It's me.
As I said earlier, this happened before the electric grid, and also before terms like volts, amps, ohms, and coulombs. These electrical units were established 54 years later in 1861 by British engineers Joseph Latimer Clark and Charles Tilton Bright, who named them in honor of past innovators such as
Alessandro Volta,
who invented the voltaic pile, and André Marie Ampere, who was a pioneer of electrodynamics. In Davy's time, electricity was evaluated in qualitative terms based on the size and number of plates in a voltaic pile. Davy isolated potassium by using the electrical potential from what was the largest voltaic pile known at the time. He used slightly moist potassium hydroxide. To free up the potassium ions from the crystal lattice, the salt is heated above 300 degrees until it is molten. He melts this on a plate anode, where a platinum cathode is brought into contact with the molten salt. Negative electrons from the cathode reduce the positive potassium ions to potassium. Hot potassium is highly reactive with oxygen and moisture in the air, and this would catch on fire, showing its brilliant lilac emission, resulting in a mixture of potassium peroxide, superoxide, and hydroxide.
Of course, I knew all along. I mean, I was just having a rest from all the fame and prestige. The prestige? Dance with me, Lucius. Dance, I believe, to show that chemical affinity is fundamentally electrical in nature. I didn't make powered voltaic battery for nothing. Look at this. It's composed of 250 pairs of zinc and copper plates, 4 by 6 inch.
250. Copper, zinc, 4 by 6. At a guess, I'd say that's 100 to 200 volts.
What's that?
Just calculating. Nothing. So that's potash you have there on the conductor plate, and it's kept molten like that, just from electrical resistance.
Yes, slightly moistened, but not too much. It can be a bit dangerous, explosive, but those shiny metal beads are quite something.
This is quite an impressive and informative discovery, don't you think? Sir Humphrey, sorry, Mr. Humphrey, next week you'll be discovering sodium metal too, knowing you. I must be off, but it's been an electrifying experience as usual.
Yeah.